All right, this next concept that we're talking about is transformations. There's 4 different types of transformations, and we're going to talk about 2 of them today. But first, we need to talk about what a transformation is. So, a transformation is an operation that maps an original figure, which is called the pre-image, onto a new figure called the image. So, what we originally start with is a pre-image, and it's making a new image. A transformation can change the size. It can change the position. And it can change the orientation of a figure. And there's 4 types of transformations. We have translations, reflections, rotations, and dilation. Okay? The one we're going to talk about next is called the reflection. So first we need to know what it is that we're reflecting. Well, it is a flip. It is a flip over a line called the line of reflection. Which makes sense because it's like you're looking in a mirror, the reflection. So if the mirror was our line, it's what we see back. So each point and its image are the same distance from the line of reflection. The x-axis and y-axis are common lines of reflections. And what do reflections result in? They result in congruent polygons. So we know what congruent means, that everything, the shape it remains the same. Angles are the same, sides are the same, distance. The only thing that changes in a reflection is it's a flip across an axis. So let's talk about how we find them. All right, move this up. So we're going to do the left side together, and then we're going to come up with some rules. So we're going to do 1 and 3. Okay, so triangle ABC with vertices 1 and 6. So first I'm going to plot the points. This, of course, is my x-axis and my y-axis. So here's 1, 6, 1, 2, 3, 4, 5, 6. So that's where A is. My B value is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Up 3, that's my B. And C is 4, 2. So 1, 2, 3, 4, 1, 2. So here is my 3-dimensional figure. Notice A, B, and C are all capital letters. It represents that. So if I want to find, if it's asking me to flip it over the X, that means I would literally fold my X paper in half and C, if it's 2 units from the x-axis, it would still be 2 units from the x-axis here. And what is this point of C? It would be 1, 2, 3, 4, 4, negative 2. So C is 4 and a negative 2. My value of, and notice I'm putting this little tick mark there. So it's C with that little tick mark. That means that's my image. This is my pre-image, my original. My tick mark is the one that has my image. That's the image I'm talking about. So C with the tick mark. Now you'll notice B is 3 units up, so it's going to be 3 units down. And this point would be 8, negative 3. Okay, that's my B value. And my A value is located 1, 2, 3, 4, 5, 6 units up from my x-axis, so it's going to be 6 units down. So this is, so if it's still 1 and it's negative 6, okay? Now, let's do this next one real quick. Triangle PQR with vertices P is, oh, you know what? Let's stick to it. No, it won't. Okay. Shoot, I was hoping we could see a pattern. I want to wait to see the patterns at the end. Okay, so do this triangle, we have vertices -8. So here's my x-axis, here's my y-axis. So -8, 2, 4, 6, 8, and -6. So there's P value. My Q is -5, 1, 2, 3, 4, 5, -2. That's my Q value. And 2, -1. Okay. All right, so there's my original image. So my pre-image. So my new image, if P is located 6 units down from my X, it's now going to be 6 units up. 1, 2, 3, 4, 5, 6. And this is going to be 8, +6. I want you to keep in mind, look at my coordinate points. Okay, oh, that's -8. So it's still -8 and it's +6. My Q value is going to be, it's 2 units down, so now it's going to be 2 units up. And that point is located at -5, +2. Let's see if we can find a pattern. That's Q, and again, they have those marks there. And my R value is going to be 1 unit down, so it's 1 unit up. And so now, there's my image, and this line is to +1. So is there anything that you notice from these ordered pairs to here? All my X values stay the same. My X remains the same. The only thing that's changing is my Y value. It was negative, it becomes positive. It was negative, it becomes positive. Negative to positive. Okay, so keep that in mind. That's the X-axis. Let's do a couple more. Do a rhombus. So now let's do number 5. So we got -4, 7, 1, 2, 3, 4, and then 3, 6, 7. There's -4, 7, that's C. And then D is -2, 4. E is -4, 1. And F is -6, 2, 4, 6, and 1, 2, 3, 4. Okay, so, what am I doing? That's F. All right, so now I want it reflected across my y-axis. So I would fold this over here, and what happens? My new D vertice is going to be +2, +4. That's D1. My new C value, if it's 4 units here to the left, it's still going to be 4 units to the right, but it still remains +7. So now it's going to be 4, 7, C1, and my F value is located 1, 2, 3, 4, 5, 6 units to the left, so it's going to be 6 units to the right, 1, 2, 3, 4, 5, 6. That's my F value, my new one. And my E value, if it's 1, 2, 3, 4, it's going to be 1, 2, 3, 4. And there's my new image. So F, you'll notice, is going to be +6, +4, and my E value is going to be +4, +1. So what happened here? When I'm reflected over my y-axis, my y values stay the same. So when reflected over the y value stays the same, but my x value, it's the opposite. It was -4, now it's +4. -2, +2. -4, +4, -6, and 6. Okay, so that's how that relationship works. Let's do one more with the graph and then see if we can figure it out without graphing them. So number 7, let's look at triangle. So we have 3, -1, that's M. We have 6, -8, that's N. And then we have 1, -3, that's P. And we are reflecting it across the y-axis, so it's going to come this way, the reflection is. So P, it's 1 unit here, it's 1 unit there. M is 3 units here, 3 units here. And my n value is going to be 6 units here, 6 units here. There's my reflection, so it looks good. And now let's see what happened. Notice my y values stay the same. M is still on the -1 line. Q is still on the -3. And n is still on the -8. So my y value for m stayed the same. The only thing that changed is before where it was +3, now it's -3. My n values stayed, my y value stayed the same, -8. But my x value is going to be -6. And p, my y value stayed the same as -3, but my x value is going to be -1. So on your y-axis, the y value stays the same. It's the x coordinate that has flipped. So when you look down to the end, and we come up with a rule, here's the most important part. The pattern of the reflection. When it's reflected across the x-axis, the x value stays the same. It's the y value that changes. So if it was positive, it's going to be negative. If it was negative, a negative times a negative, that value would become positive. That's why this means opposite. And the y value, if it's reflected over the y-axis, my y value remains the same. It's my x value that is the opposite. So we don't have to graph them per se, but we can always just kind of look at that information and look for the pattern. So if you look here, here's my triangle LMN, and it undergoes a reflection with the coordinates 8, -2, 3, -1, and 1, -8. What is the line of reflection? Well, which value is not changing? -2, -2, -1, -1, -8, -8. So my y value is not changing, so it's reflected across the y-axis. Okay, that's how we figure that one out. Over here, it says which pair of points represents a reflection across the x-axis. So if it's a reflection across the x-axis, my x value stays the same. Well, that doesn't stay the same. 0, -3, that doesn't stay the same. 4, -4, that doesn't stay the same. 1 and 1, my x value remains the same. D would be my answer. Okay, so that's a reflection. If you have questions, come see me.